Okay, I would like to start the topic for today, which is quadrature phase shift keying modulation. So we are in the next topic. Let's recall a few concepts before uh, actually going to the real topic. Let me give you a few concepts. Uh, and we learned about the mm, uh, orthogonal signals, and we know that if we have two signals, like if I have two sinusoids, suppose s1 of t is a sinusoid which is we can say sine of uh, 2 pi f ct, and I have another sinusoid which is s2 of t, which can be written as sine of 2 pi, or let me call it cos of 2 pi. This is cos of 2 pi fct. If I have these two sinusoids, these are orthogonal. We can always verify that the integral of these two, s1 of t and s2 of t, if we find out this integral, this would be equal to 0. Another important property along with this one is actually the arithmetic identity which we will use today, and that identity is cos of alpha plus beta, a well-known identity which is equal to cos of alpha cos of beta minus sine of alpha and sine of beta. We'll use this identity today, right? So well, let me recall another concept which we already studied in my previous lecture, and we learned that if we have we can observe signals in the Euclidean space, where we represent the psi1 of t and represent these x's by orthonormal basis functions, or two orthonormal signals. So any signal, any point over here represents a signal point, and a position vector. A position vector represents actually a signal, and the image of this vector, we can say that there are two images on x-axis and y-axis, and these images are we can say these are the image of the signal on psi1 axis and psi2 axis, right? And if we have this type of signal which we can represent by s, then we can always write our signal as a linear combination. Let me specifically say s of t. We can always write our signal s of t as a linear combination of psi1 and psi2. So this can be written as psi1 t plus b times psi2 of t, and a, b are of course these rectangular components, and b are these rectangular components. So this is just a prereq of our topic today. That is why I just repeated these concepts, a concept of orthogonal signals, this mathematical identity, and the concept of signal space, where we use this concept to represent our signal as a linear combination of orthonormal basis functions. So these concepts will be useful. If anybody is still not clear about it, just go through my previous lectures so that you better understand the QPSK modulation scheme, which is a digital modulation scheme, and supported in the 4G of wireless communication.